In this class, we're going to solve tutorial sheet 4, Math 1120, 2025. Okay, so we're going to be solving random questions. All the solutions are already posted on the drive. Okay, so the first question is solve the radical equations below. Those are the radical equations. So videos, we've done them on radical equations. You can still access all those ones on the drive. So let's start with the first question. Okay, so the first question is x minus 3 is equals to, okay, the square root of 5 minus x. Okay, I must remind you that you know the way you solve radical equations. Let me say you have the square root of x is equals to a 1. So the way you're going to do this, you square on both sides. Okay, so the square and the root will cancel, so you have x is equals to 1. The one that you found, you have to test it in the equation if it will really satisfy the solutions. So you're going to say the square root of 1 is equals to 1. The square root of 1 is just a 1 or a positive or a minus 1, so we're just going to get the positive 1. Hence 1 is a solution. Okay, you must know that. Now that's the same principle we are going to apply throughout all the questions. So I'm not going to solve all of them. I'm just going to be picking randomly. Okay, so we'll do the same. So I'm going to square on both sides. Okay, so you know how we square. If I say a minus b, this is squared. What am I going to do? Square the a, square the b. Okay, then what are you going to put in the middle? Multiply 2 by a. The answer that you get, again multiply it by negative b. So I'm just going to have negative 2a b. Okay, plus. So this will be your simplified solution. So that's what we're going to do as well for these expressions that we have. Okay, let's start with our expression on our left hand side. So we're going to say 2 multiplied by x, so that would just be x squared. Okay, 2 multiplied by x, that's a 2x multiplied by negative 3, you're going to have negative 6x. Okay, minus, or then you square root there. You're going to square negative 3. Negative 3 squared, that is just a positive 9. Okay, this is equals to, we come to the other side, so the square and the root will cancel, so this side we're just going to remain with 5 minus x. Then when we reach here, what are we supposed to do? We can put the like terms together. So I'll say x squared minus 6x. When I take the negative x to the other side, it becomes a positive, so I have positive x, I have a plus 9, and when I take the 5 to the other side, it becomes a negative 5. So I have negative 5 is equals to 0. Then we simplify. So I have x squared, negative 6x plus x. That just gives me negative 5x. Okay, then 5 minus 9 minus 5, that is just a 4 is equals to 0. Then we have a quadratic expression with us. So how are you going to do? First try the product, the sum, and the factor method. If it doesn't work, then we're going to use the formula method. So how are you going to find the product? You're going to multiply 1 multiplied by 4. Okay, that just gives me a 4. Okay, then the sum, always get your b, or the coefficient of x, which is negative 5. Now which two numbers can we multiply to give us a 4, and when we add those numbers they'll give us a negative 5. So negative 4 and 1 will be able to achieve that. So what our solution is going to be? It will be x minus 4, x minus 1 is equals to 0. So therefore the values of x, we have x is equals to 4 and x is equals to 1. Now these are the solutions that we have. Then like we earlier said, test your solutions in the actual equations to see if they really satisfy the equation. So we've got x minus 3, this is equals to the square root of 5 minus x. Okay, so what do we do? Let's start with 4. If we say we put 4 here, 4 minus 3, 4 minus 3 is equals to the square root of 5 minus 4. Okay, 4 minus 3, that is just a 1, is equals to the square root of 5 minus 4, that is just a 1. Then 1 is equals to the square root of 1. So we're going to, so 4, we're just going to get the positive because the square root of 1 is positive or minus. So the positive one is a solution, the negative one isn't a solution. Let's try 3. What if, let's try 1, this one. What if we put 1 where there is x? Let's say we put a 1 here. 1 minus 3, that will just give us a negative 2 is equals to, then we have 5, 1 minus 3, yeah, it will give us a negative 2. Then if we say the square root of 5 minus 1, okay, 5 minus 1, that is a 4. Then a 4, the square root of 4, that will just be a positive or minus 2. So in that regard, what are we going to have? We're going to have we're just going to get the negative answer because it's the one that will satisfy this solution. Okay, so 4 and 1 are solutions, but with restrictions. Only the other one is positive, the other one is negative. Okay, so that's how we go about this question, and the same applies to all of them. Which other one can I solve just for clarity's sake? Okay, let's try this one with a lot of squares. Let's try C. Okay, so your C is the square root of x minus plus. Okay, so the square root of the square root again of x minus 5 plus x. Okay, so this whole thing is in a square root like that, not really like that. Okay, so the x is alone this side. Okay, this whole square like that is equals to 5. So how are we going to do the same scenario? Square on both sides. So I'm going to square on both sides, this side squared and on my right side squared. So now what do I do? The square and the root, the first root will cancel. So this side I'm going to remain with the square root of x minus 5. Okay, this is in the root, plus the x is isolated, is equals to 5 squared, that is just a 25. So I'm going to take the x to the other side. I'm going to remain with the square root of x minus 5 is equals to 25 minus x. Okay, now at this juncture I'm again going to square on both sides. So I'll square and also square like that. Okay, I want to cancel the root. So what am I going to do? So the square and the root will cancel. So I have x minus 5. This is equals to, how did we solve the other one? So you're going to say 25 squared, that is just like a 625. Then you're going to multiply 2 multiplied by 25. 2 multiplied by 25, that is just like is it 2 multiplied by 25? That is like a 50. Okay. Okay, 2. Okay. That is like a 50. Okay. A 50 multiplied by negative x, so I'm going to have negative 50x. So here I'm going to have negative 50x. Then the negative x squared, it will just give me positive x squared. Okay, then what am I going to do? I'm just going to put the like terms together and solve. Okay, so let me leave a 0 here. I'll say 0. I'll take everything to the other side. So 25, 625, then, or 625 actually. So this is 625. When I take the negative 5 to the other side, it becomes a positive. Okay, so I have a positive 25 positive 5, okay, minus 50x. I'm going to take the x to the other side as well, so it will be negative x, right? So I have negative x plus we have an x squared. Okay, so we can solve 0 is equals to 625 plus 5, that is just a 630. Okay, then negative 550x minus x, that's just give me a negative 51x plus, okay, is it plus? Yes, plus your x squared. Now with me here I have a quadratic expression. Okay, so allow me to rub on top. Okay, and allow me to get the calculator. Seems like we were dealing with big numbers. Okay, so this is the expression that we end up with. Okay, so how are we now going to do that? So we are saying, let me write it in this form. X squared minus 51x, the standard form, okay, and we've got a plus 630. This expression is goes to 0. So now what do we do? Okay, we have to look for two numbers that we can multiply. They'll give us a 630, and that is like the product. Then the sum, they'll give us negative 51. Okay, so in that regard, I'm just going to use my calculator. Okay, so two numbers. So let's say negative 35 and negative 18. So if I add negative 35 plus negative 18, you're able to see that 5 plus 8, that is just 5 plus 8 is what? Whatever. Yeah, so when you add those ones, they'll give you negative 51, but when you subtract, when you multiply, they should give you 630. Okay, so our solutions therefore will be x minus 35, x minus 18. This whole expression is equals to 0. So therefore x will be equals to 35 or x will be equals to 18. Then you check your solutions. So when you check your solutions, because these are big numbers, when you check your solutions, you find that only x is equals to 35 will be your valid solution. Okay, only x is equals to 5 will be your valid solution. Okay, let's solve another one. Let's also solve d. D is the square root of 5 minus x plus 1 is equals to x minus 2. Okay, allow me to rub here. So we're saying d is, we're saying it is the square root of 5 minus x plus 1 is equals to x minus 2. So likewise, we are going to take the negative 1 to the other side. So we're going to have the square root of negative 5 minus x is equals to x minus 2. Then when I take the negative, the 1 to the other side becomes a negative. So I have minus 2 minus 1, that will give me a minus 3. Then now when I have these expressions, I'm going to square on both sides now. So I'll square this side, I'll also square this side. On the left hand side, the square and the root will cancel, so I have 5 minus x, this is equals to then x squared. So I have x squared, then 2 multiplied by x, that's 2x, 2x multiplied by negative 3, that is negative 6x. Then the negative 3 squared, it will just be positive 9. Okay, then what are you going to do? You are going to again put the like terms together. Okay, so I'll have let me say 0 is equals to x squared minus 6x. When I take the negative x to the other side, it becomes a positive. So I have positive x plus a 9. When I take the 5 to the other side, it becomes a negative. So I have negative 5. So 0 will be equals to x squared negative 6x plus x, that's negative 5x, positive 9 minus 5, that is just a plus 4. So with me here again I have a quadratic. So how do we solve quadratics? It's just the same. If you again, you have to look for the product, the sum, and the factors. Okay, so what is the product in this case is 4. The sum is 5. I think we solve something like this. So in this case we're talking about negative 4, the factors, and negative 1. Okay, so what you're going to have is 0 is equals to x minus 4 or x minus 1. So therefore x would now be x is equals to 4 or x is equals to 1. Then you test your solutions to find which one is a valid or an invalid solution. Okay, good. Okay, which other one can we solve? Okay, same which one is a bit different? Okay, let's solve f. Let's try f. Let's try f, this one. 2 plus the square root of x minus 2 is equals to the square root of 2x plus 3. Okay. So if we are going to solve f, we are saying it is 2 plus the square root of x minus 2. This is equals to the square root of 2x plus 3. Okay, so what am I going to do? I'm just going to again to square on both sides. So I'll square this side. I'm also going to square this side. Okay, this is really interesting. So the 2 on my left hand side. So this 2 will multiply with this one first, and we're going to square this, and we're going to multiply 2 multiplied by 2 and multiplied by this expression to find what will be on the middle. So let's just do that. So we're saying 2, so 2 squared, that is just a 4. Okay, plus, okay, 2 multiplied by 2, that is a 4. A 4 multiplied by everything that is in the root, so I have 4 with everything that is in the root, x minus 2. Then again I'm going to square the last part. The last part is just this expression that has a root, so it just means that the root will cancel. So I'm going to remain with x minus 2. Hope we are good on that one. Is equals to the square and the root will cancel on my right hand side. I'm just going to remain with 2x plus 3. Okay, hope this is resonating. Now let's proceed. What are we now going to do? You can put the like terms together and you solve. Okay, so let me say okay, so let me say 4 the square root of x minus 2. I'm going to take everything to the other side. I'll just leave this one this side. Is equals to 2x. Okay, I've got okay, 2x. Then this, when it goes, the x when it goes to the other side becomes a negative. So I have negative x. Then I have a plus 3. When the 2 goes on the other side, when the 2 goes on, the negative 2 goes on the other side, becomes a positive. So I have a positive 2. When the 4 goes on the other side, it becomes a negative. I have minus 4. Okay, hope we've taken everything on the other side. So I'm going to say 4 root x minus 2. This expression is equals to 2x minus x, that's just x. Then 3 plus 2, that is 5. 5 minus 4. 5 minus 4, what is it? Okay, 5 minus 4, what is it going to give us? Five minus 4, that is like, let's say 3 plus 2, that is a 5. A 5 minus 4, that is just a 1. Okay, plus 1, like that. So what are you going to do? You're going to again, square on both sides. So when you square 4 squared, that is just like a 16. Then this expression squared, you just going to remain with x minus 2 because the squares will cancel. On the other side, you have x squared plus 2x plus 1. Okay, then what are you going to do? What are we now going to do? If we say, so you're going just to on the other side, you're going to distribute. You're going to say 16x minus 32 is equals to x squared plus 2x plus 1. Then you put the like terms together. 16x, when I take everything on the other side of x squared, 2x minus 16x, when I take the 16x to the other side, becomes a negative. So 2x minus 16x, it will give me negative 14x. Okay, then the 32, the negative 32, and take the other side, becomes a positive. So I have 1 plus 32, I have like a plus 33. Then you solve this quadratic expression. Okay, so that's how you solve these questions. Very simple and very straightforward. Let's go to question number 2. Question number 2 is solve each of the following equations. Okay, solve each one of the following equations. So these are modulus equations, and you know the rule of the modulus. What is in the absolute function? Let me say x, this is a, should always be positive. Okay, should always be positive. Whether if we say this, the modulus of negative a, it should always be positive. Okay, that's what we're talking about. So even in this expression that we've been given, just make sure that you follow that principle. Very simple to solve. Another expression that I can give you, if we have the modulus of x is equals to 1, the way you're going to do is that when you want to remove the modulus functions or the absolute functions, you're going to say x is equals to 1, which is positive. Again, you're going to say x is equals to negative 1. Okay, that you must know. These are modulus equations. Then for modulus inequalities, if we say the modulus of x is, let's say it's greater than 1, for modulus inequalities, you're going to say to be x will be less than 1, or x will be, the sign will change and the symbol of the number will change. You say negative 1. So that's what you're going to do for inequalities. So with me here, I've got equations. So let's solve these equations. Hope you're paying attention. So we are saying a is 2x minus 1. Okay, then the modulus is equals to x plus 1. Okay, so what are we going to do? I'm going to do the same like I just showed you. So I'm going to say 2x minus 1 is equals to, when I remove the modulus, I can have x plus 1, which is just positive. Then on the other side, I can have 2x minus 1 is equals to negative, in this case, x plus 1. Okay, so then I solve these equations. So I'm going to have 2x, when I take the x to the other side, becomes negative x is equals to 1. When I take the negative 1 to the other side, it becomes a positive 1. So I have positive 1. 2x minus x, that's just x, is equals to 2. Then on the other side, on my right hand side, if I solve this, I'm going to have 2x minus 1 is equals to, let me distribute the negative. So I'm going to have negative x minus 1. Then I solve. So I'm going to just do it. So I'm going to take the negative x to the other side. It becomes a positive x. Then 2x plus x, that's just like a 3x is equals to, I've got a negative 1. When I take the negative 1 to the other side, I'm going to get what? A 0. Then I'm going to divide by 3 on both sides. So x will just be equals to to 0. Okay, x will just be equals to 0. So those are my solutions. I'm going to have is it really going to be 0? If I let me say negative, that's negative x, that is negative 1. When I take 1 to the other side, it becomes a positive. Okay, yeah, so that's how it's going to be, and like that. So it's going to, that's going to be 0. So that's how you solve the first one. You find your solutions, then you can also test your solutions to see if they are correct. Okay, now let's solve the next one. You can also solve B. We have the modulus of 4x plus 3 is equals to 3 minus x. So likewise, I'm going to do what I did earlier. So I'm going to say 4x plus 3 is equals to, I'm going to get the positive part first, or 4x can be 4x plus 3. Let me just write it a bit on top. Okay, so I'm saying 4x plus 3 is equals to negative, okay, 3 minus 1. Then I'm going to solve. Let me start with my left hand side. I'm going to say I'm just going to put the like terms together. Okay, so when I put the like terms together, I'm just going to have 4x is equals to 3 minus 1, that is just a 2. When I take the negative, the 3 to the other side becomes negative. Okay, so on this side, what am I going to have? I'm going to have I'm going to divide by 4 on both sides. Okay, so x will just be what would be our x? So x is just going to be, that is that negative 1 over 4. Okay, on this side. When you come to the other side, first distribute the negative. So 4x plus 3 is equals to negative 3 plus 1. Then what I'm going to do, you're going to say 4x is equals to negative 3 plus 1 to be negative 2. When I take the 3 to the other side, becomes negative 3. So I'm going to divide by 4 on both sides. So our x on this side will just be x is equals to negative 5 over 4. Okay, so that's how we are going to solve this one. Okay, which other one can we solve? Okay. Let's solve which one? Because the same principle. Let's solve the one that has modulus on both sides. Let's solve D. So 4x plus 9, the modulus of that is equals to the modulus of 2x minus 1. So likewise, what am I going to do? So it's the same principle. I'm just going to say 4x plus 9 is equals to 2x minus 1. Again, I'm going to say 4x plus 9 is equals to, now it will be minus, okay, 2x minus 1. So then I'm just going to solve. So 4x minus 2x is equals to negative 1, negative 9. That will give, on this side, I'm just going to have 2x is equals to negative 10. So therefore your x will just be like something like, is it a negative 5? Yeah, something like a negative 5. Then you come to the other side, 4x plus 9 is equals to negative 2x plus 1. Then I'm going to put the like terms together. 4x, when I get the 2 to the other side, it will just be positive. That will just be like 6x is equals to 1 minus 9. Okay, so I've like that I divide by that, then your x will just be like 1 minus 9, that is just like a negative 8. Negative 8 over 6, that will just be like negative 4 over 3, like that. So that's how I'm going to be solving these modulus equations. So very simple and very straightforward. Let's solve one that has a quadratic. Okay, so let me start with E, or let me solve E. So I've got the modulus of x squared minus 4x modulus is equals to 12. Okay, so it's the same thing. I'm just going to say x squared minus 4x, this is equals to 12, or x squared minus 4x is equals to negative 12. Okay, so then I'm just going to solve. So what am I going to have? This side I'm going to have x squared minus 4x minus 12 is equals to 0. Then this side I'm going to have x squared minus 4x plus 12 is equals to 0. Then I solve these equations. Okay, this quadratic, we know how to solve quadratic expressions. Okay, so this is how we're going to solve this one. Same with all these other ones. As long as it's a quadratic, just solve them. They will solve quadratic expressions. Okay, so that's how you are going to go about these questions. Let's go to the next questions. Let's go to question 3. Sketch the graph of the modulus functions below. In each case, use your graph to state the range of the function. Sketch the graph of the modulus function. In each case, use your graph to state the range. So we have to use the graph to state the range of the function. Okay, very simple. How do you graph modulus functions? Let's start with the first one, 2x plus 8, the modulus of 2x plus 8. Allow me to use the next page. We're saying f of x is equals to the modulus of 2x plus 8. So how are you going to do? For you to find where your graph starts, because what is in the modulus is a shift in the x. So you're going to say 2x plus 8 is equals to 0, then you solve. So you're going to have 2x is equals to negative 8. You're going to divide by 2 on both sides. X will just be equals to negative 4. That's where your graph is going to start. Okay, to find the intercept at that point, or the y-intercept, if at all it's going to cut the y-intercept. So you're going, wherever there is x, you're going to press 0. So the y-intercept, if at all it's going to have a y-intercept, you're going to say f of 0 is equals to 2. Wherever there is x, we place 0 plus 8. This is in the modulus, don't forget. So 2 multiplied by 0, that is just a 0. So you're going to just remain with the modulus of 8. The modulus of 8 is 8. So that would be the y-intercept. The x-intercept, put the whole expressions to equal to 0. So now I think what I have right now, it's very, very enough, because we know where the graph is starting. So let's see the behavior of this graph. So this is our x-axis. So now what do we now do? I'm saying the graph x is equals to negative 4. That's where your graph is starting. So let's say our negative 4 is there. Okay, then we don't have any shift in the y-axis, so it's just going to start at negative 4, 0. So this same point, that's where it's going to start from. So how is the graph going to go? So the graph is going to go in this direction, or the graph is going to go also in that direction. Now what you must realize is that if you want, you can plot, you plot numbers, you choose from negative numbers. Let me say you choose negative numbers of x. You can draw a table of values. Negative number, you say x and y, then you do like that. Then you can start from the negative numbers of x. Maybe let's say negative 1. You put in this equation, you find your answer, you plot. Okay, if negative, let's say, let me just give a scenario. If I say negative 1, if I put negative 1 here, I put negative 1 multiplied by 2, that is negative 2. Negative 2 plus 8, that is 6. So the modulus of 6 will just be a 6. Okay, then if I put a 0 there, I'll just have 8. If I put, maybe let me say a 2, that is 4. 4 plus 8, that is just like a 12. So if I'm going to plot these values, you're going to realize that you're not going to have any value of y that is negative. Why? Because in the modulus function itself, whether you put a negative x or a positive x, you're going to always end up with a positive number. Hence, you look at the behavior of the graph, all the values are going to the positive values of y. Okay, so that's how the graph is. And now you're able to notice that this graph has cut the y-axis at that point. That point, we've already found it. It is the y-intercept, which is 8. So this point is 8. So this is how you graph this function. So that's how we're going to do for all of them. Okay, all of them. So we also did videos on the modulus functions. You still can access them on the drive. Okay, let's solve another one. Personally, I love graphing. I love graphs. I enjoy them. So let's solve b. F of x is equals to 3x minus 6. Okay, so we're saying f of x is equals to 3x minus 6. This is in the modulus. Okay, so you're also able to see there is no shift in the y-axis, so even better and even straightforward. So get what is in the modulus equated to 0, so that you find your shift in the x. So we're going to say 3x minus 6 is equals to 0. So therefore your 3x will just be equals to 6. Then your x will just be equals to a 2, right? Good. So that's where our graph is going to start from. So this, I think, is enough to draw our graph. So let me say this is the y-axis, this is the x-axis. Okay, then let's say our 2 is there. So then how is our graph going to go? You know that the modulus will just go in that direction and in this direction. Now you're able to see that the graph cuts the y-axis at that point, so you have to find that point. So what is this point? It's on the y-axis. On the y-axis, x is equals to 0. You have to remember that the y-axis is just the same as x is equals to 0. The x-axis is just the same as y is equals to 0. It means that if you're talking about the x-axis, every point on that line, y will be equals to 0. Same with on the y-axis, every point on that line, x will be equals to 0. So let's find the y-intercept. So we're going to say f on the y-intercept, x is equals to 0. So f of 0 is equals to the modulus of 3, 0 minus 6. Okay, so we're going to have the modulus of 3 multiplied by 0, that's just a 0. You have a negative 6. The modulus of a negative number, it's just going to be a positive number, so only have a positive 6. Hence this point, the y is casting the y-axis is 6. So that's how you solve this one. Very simple and very straightforward. Let's solve another one. We have c. Okay, 8 plus the modulus of x plus 4. Good. Okay, okay, so let's just do that. So we are saying f of x is equals to, we are saying 8 plus the modulus of x plus 4. So how are we going to do again? Get what is in the modulus function equated to 0, so that you know the shift in the x-axis is equals to 0. So x will just be equals to negative 4. So we have a point negative 4. Then where is your graph going to start? We are also able to see there is a shift in the y-axis, which is just 8. So if we're going to draw, this is just enough for us to draw the function, the graph. The goodness with modulus functions is that they are very simple and very straightforward. Okay, so I explained all the principles, I explained all the combinations in the videos. They'll be also helpful. So we're saying x is equals to negative 4. Let me say my negative 4 is here, and we also have a shift of 8, Okay, so it means our graph is going to start there. Okay, then how are you now going to draw? Okay, let me just increase this to like that. Okay, so now what are we now going to have? So how is our graph going to go? Look at the value of the function. This function here, the modulus function, is positive, so we're going to get the positive values of x. Okay, so what are we going to have? So the way we're going to draw this is it's just going to move in this direction and in that direction. Now we're able to see that it cuts the y-axis at that point, so you have to find that point. Okay, you have to find that point. So what is that point? You know that on the y-axis x is equals to 0, so I'm just going to say f of 0 is just equals to 8 plus the modulus of 0 plus 4. So this will just be equals to 8 plus 0 plus 4, that is 4. The modulus of 4, that is just a 4. 8 plus 4, that is just a 12. So therefore this point here is a 12. You are done. Very simple and very straightforward. Let's solve another one. So this one, well, let's solve d. D is 4 minus, okay, now we have a negative number. Let's see how it's going. 4 minus x plus 3. Okay, so let's solve. So we're saying f of x is equals to 4 minus, you know, the modulus of x plus 3. So what are you going to have? That's the same. Okay, let me just draw the graph in advance, because modulus functions, they are easy to determine, and to see the behavior of the graph doesn't really require a lot. So you're able to see, you equate what is in the bracket in the modulus to be equals to 0. So x plus 3 is equals to 0, so x will just be equals to negative 3. So that's where our graph is going to start in terms of x. Then you're able to see that we have the shift of 4 units in the y-axis. So our 4 will just be there. So it means our graph is going to start from here. But now look at the value of the function. You're able to see that the value of the function is negative. There's a negative here. So because it's negative, it's going to go down. Okay, it's going to go down. So how is it going to go? Now this graph, it can either go this way like that, or this same graph can cut and go like that. Okay, so now how do we determine where the graph is going to pass? Just find the y-intercept where it's going to cut the y-axis. On the y-axis, x is equals to 0. So as we're going to say f of 0 is equals to 4 minus the modulus of 0 plus 3 is equals to 4 minus the modulus of 0 plus 3. Okay, that is you're just going to have the modulus of 3. So 4 minus the modulus of 3, that is just 3. 4 minus 3, that is just a 1. Okay, a 1. Let's say our 1 is here. Okay, so you're able to start it's that point. So it means that this graph, as it's going to go, it's also going to cut the x-axis. So now you're able to see. So you also have to find this point at the x-axis. Okay, on the x-axis, what did we say y is? We said y is equals to 0. So get the whole expression. Where there's f of x, put 0. So it will be 0 is equals to 4 minus x plus 3. Then you solve this modulus equation. So you're going to say 0 is equals to 4 minus, I'm going to distribute how did we solve? I'm going to take, let me do it like that. Okay, we've been solving this modulus. I think that was the first question where I was solving modulus equations, right? So I'm going to take the modulus, the negative with the modulus on the other side. So I'm going to remain with x plus 3, okay, is equals to, I'm going to just remain with a 4 this side. So how do I remove the modulus? It's the same principle. So I'm going to say x plus 3 is equals to 4 or x plus 3 is equals to negative 4. Then I solve these two equations. Okay, I'll solve those two equations. So when I take the other side to the other side, when I take let me solve the first one. So when I solve the first one, x will just be equals to 4 minus 3, that is just a 1. Okay, then on the other side, when I say x is equals to negative 4 plus 3, that is a negative 1. But now you're able to see that you can't have a negative 1 here because these are positive numbers. So you're just going to get the one which is x is equals to 1. Okay, so that is the solution. That's why you always test your solutions to see where they really lie. Okay, so this point is just a 1. Therefore now your graph, the way it's going to look is it's going to go, oh, actually we found two answers, right? Even better. So the other one found that it is negative 1. So negative 1 will be here. Okay, good. Then we graph. So it's going to pass through these points and also at negative 1. So this is how you graph your modulus function, like that. Very, very simple and very straightforward. Okay, good. So now that we've solved modulus functions and how to graph them, let's go to question number 4. Solve each inequality and show your solution set on the number line. Okay, I think when I was introducing, I talked about something to do with inequalities. So what are you going to do? You're going to say 2x minus 7, this is a is greater than 8. So how are you solving this one? So like I earlier said, get what is in the modulus. 2x minus 7, this is going to be greater than 8. Okay, then again you can get the same expression. You're going to say 2x minus 7 is less than. Okay, it should be less than. When you change the sign of the other number also changes. That's what I said, negative 8. Then you solve these two equations. Let's start with the first one on my left hand side. So I'm going to say 2x is greater than 8 plus 7. I'm going to divide by 2 on both sides. Okay, so x therefore just be 8 plus 7. 8 plus 7, that is just like is it a 15? Yeah, a 15. A 15 divided by 2, that is like 7.5. So x is going to be 7.5. On the other side, if I solve, I'm going to have 2x is less than negative 8 plus a 7. So 2x is greater than or is less than negative 8 plus 7. Negative 8 plus 7, that's just a negative 1. I'm going to divide by 2 on both sides, so x will just be less than negative is it negative half? Okay, negative half. You can divide negative half, so x will just be negative 0.5. Therefore now what will be your solution set? So they have asked us also to find the solution set on the number line. So you can draw a number line. So allow me to write it here. So let me say this is our number line. Okay, so what are we going to have? We are saying we have, let me say we have negative 0.5, let me say 0 is here. Okay, then let me say our 7.5 is there. Okay, so what do we want? So this, are you going to shed? No, you're not shedding this negative 0.5. Why? Because look at the symbol. X is less than is negative 0.5. So you want all the values that are less than negative 0.5. So they'll be going like that in this direction. You come to the other side. We've got 7.5. Is it included? No. You're also going to open. Now you want values that are greater than 7.5, so you're going in this direction. So therefore, what will be your solution set? You're able to see that your solution set in this case, you want all the values of x. So x is a member of, you want all the values from negative infinity to, a negative 0.5. This is union. Again, you want all the values from 7.5 to all the way to positive infinity, if you want to express it in set interval notation, or you also draw the number line. Simpler and straightforward. Good. Then we can also solve b. Can also solve b. So how are we going to solve b? You're going to say 2x minus 6, okay, that x plus 4. Okay, same principle, nothing changes. So you're going to say, is it 2? Yeah, 2 that 2x minus 6. So you're going to have 2x. Let me just use a different color. So you're going to say you have 2x minus 6. This is greater than, get the positive one first, okay, then you can also get the negative one. You're going to say 2x minus 6. This is you change the sign, okay. Don't forget, when you're writing the other one, you change the sign or you change the direction of the inequality, then you negative the expression that you've been given. Good. So let's solve the first one on our left hand side. We're going to say you got 2x minus x is greater than or equals to 4 plus 6. 2x minus x, that's just x. This is greater than or equals to 4 plus 6, that is just a 10. Then on my right hand side, what am I going to have? I'm going to have 2x minus 6 is less than or equal to, I'm going to distribute the negative, so I have negative x, negative 4. Now in this expression, I'll put the like terms together. So 2x plus x is less than or equal to negative 4 plus a 6. 2x plus x, that is just 3x. This is less than or equal to negative 4 plus 6, that is just a 2. So these are the answers that we have. Then you draw this on the number line. Okay, anyone who can fail to draw this on the number line? Okay, let's say this is our number line, and how we're going to put them. So it's the same principle. So I'm going to say it with 2, then this is our 10. Now we want all the values of x that are, if we are going to get, is it yeah, is it x is equals to, yeah, x is that. So for x is less, we're saying x is less than or equal to 2. So want all the numbers that are less than or equal to 2. Is 2 included? Yes. So you're going to the negative values. For 10, you're going, where we've said x is greater than or equal to 10. Is 10 included? Yes. So you shade the circle, you go to that. So you're able to see that you want all the values, from negative infinity to 2. 2 is included, okay. Union, you want all the values from 10. 10 is included. That's how I've put those kinds of brackets. You're going all the way to positive infinity. That will be your solution set. Okay, so that's how you solve the other ones. Let me also look at which one looks complicated for people. Others might also want us to solve the one that has a quadratic. Okay, let's solve the one that has a quadratic in the modulus. Okay, so which one can we solve? We'll solve d. Let's solve d. So we have x squared minus 4x. This is greater than or equal to 3. Same principle applies. So x squared minus 4x, this is greater than or equal to 3, or the next expression will be x squared minus 4x. You change the direction of the inequality, so it will be like that. Then you change also the sign of the the other expression, which is negative 3. So now what are you going to have? Let's solve on the left side. When you solve on the left side, we are going to have when you solve on the left side, what do we have? We have you're going to have x squared minus 4x minus 3. This is greater than or equal to 0. So there you have a quadratic. On the other side again, you have x squared minus 4x plus 3. This is less than or equal to 0. So now what do? You solve these two. So which two numbers can you multiply if we are going to use the product and the sum method? Let's say the product, let me just write it here: the product, the sum, and the factors. Which two numbers can we multiply? Okay, when we multiply this and this, will give us a negative 3. That will be our product. Our sum, it is just negative 4. On both expression, you're able to see that it is negative 4. Then what will be the factors? The factors, two numbers that we can multiply to give us negative 3, and when we add them, they'll give us negative 4. Okay. Negative 3, if we say this, if we say negative 3 and negative or positive 1, is that possible? Okay, is that possible? Okay, is that if we say negative 3 multiplied by our sum is negative 4. If we say negative 3 multiplied by negative 1, that is like negative 3, a positive 3. Then if we say we add those ones, will give us negative 4. So in this scenario, I think I'm not finding anything. But what I'm just finding is this one. Okay, so this one will work. So this one will work because this one will work. Why? Because you're able to see that the product is positive. Okay, it will just say positive 3. Then so we're going to have negative 3 and negative 1, because if I multiply negative 3 by negative 1, I'm going to get the positive 3. Then negative 3 plus negative 1, that is a negative 4. So this one will work. So this one will be x minus 3, x minus 1 is less than or equal to 0. So therefore x is less than or equal to 3, or x is less than or equal to 1 for this expression. So now what do you do? Those ones will be your answers. This other one, it doesn't work, so it's not a solution. So this one, which is a solution, what are you going to do? You show it on the number line. You want all the values of x that are less than or equal to 3, and you want all the values of x that are greater than, x is also less than or equal to 1. Okay, so to just be like on the middle like that. So that's how you're going to solve these expressions. Same with the e. Let's also solve e. So for e, we have 3x, the modulus of that is less than or equal to 2 minus x. So what are you going to do? You're going to say what can we do? So I can also do something very crazy here. I'm just going to say negative 3x is less than or equal to 2 minus x. Okay, if I want, just to avoid this for multiplying with my negatives, I can also say 3x is less than or equal to 2 minus x. Okay, so the inequality only changes the sign when you are changing on the other side. Okay, but if you just want to get the way it is in the bracket, you can just change the signs. Okay, that's what you do. The other side is flipping because I just want to show you another method. So the other side is, it was flipping because we were changing this side. But if you don't want to be changing this side, if you want to change the one that is in the modulus, either put it negative or positive, and the inequality will just be constant like that. Then when it's like this, you just solve normal, and you shade your expression. Let's look at other questions. Solve the rational equations below. Okay, so rational equations, they have, you know about rational equations. They are fractions. Okay, equations in form of fractions. Now for rational equations, like we said, you just cross multiply. Like, there is no big deal. But rational inequalities, you've seen that we are not cross multiplying. Okay, so that will be the difference. If you cross multiply for rational inequalities, chances are high, even 95%, that you're going to get a wrong answer. But now for equations, just cross multiply. So I'm going to cross multiply these ones. So x multiplied by, I'm going to start with these ones first. So x multiplied by x, that would be x squared. X multiplied by 3, so that is negative 3x, is equals to, I'm going to now come here, 4 multiplied by 2x, that is 8x, plus 4 multiplied by 4, that is a 4. 4 multiplied by 1, that is a 4. So I'm going to have x squared minus 3x. I'm going to take the negative a to the other side. The a to the other side becomes negative. So negative 8, negative 3x, negative 8x, negative 3x, that gives me like a negative 11x. Okay, I'm going to also take the 4 to the other side, so it becomes negative. So it becomes a quadratic. Then what do you do with a quadratic? You solve the quadratic. Okay, you solve the quadratic using the quadratic formula if you want. Okay, so that's how I'm going to solve this one. Okay, then for b, it's the same principle. You solve, let's also b. Let's see, if we're saying 1 over x is equals to x over x plus 2. So you cross multiply again. So I'm going to say x squared is equals to x plus 2. So x squared is equals to minus x minus 2 is equals to 0. So the product in this case, can this have a product? The product is negative 2. The sum is negative 1. Factors, any two numbers that we can multiply to give us negative 2, when add them, they give us negative 1. So negative 2 and 1, can they do that? Let me see. Negative 2 multiplied by 1, negative 2. Negative 2 plus 1, that is a negative 1. Yes. So our solutions will be x minus 2 and x plus 1 is equals to 0. So therefore, the values of x will have x is equals to 2, or x is equals to 1. So then you have to check your solutions. If you have to check your solutions if they are really answers. So if you put a 2 here, you put a 2 here, you put a 2, are you going to get the same answer? So this side you have half 1 over 2, but when you come this side, you've got 2 plus 2, that is just down. I've got 2 plus 2, that is a 4. 2 over 4, that is like half as well. So it means 2 is a solution. What if we put 1? If we put 1 here, we put 1 here, we put 1, are we going to get the same answer? So 1 over 1, that is 1. 1 over 1 plus 2, that is like a quarter. So they don't agree. So you're able to realize that only 1 probably will just be a solution like that. So only 2 will be a solution. So that's how you do for all of them. We can also solve we can also solve this other. Let's solve C. Let's solve C. So I'm going to solve C. You're going to say 1 plus 2x over 1 minus x is equals to 2 minus x over 2 plus x. So what I'm going to do, just cross multiply, nothing much. So let me start with these expressions. So what am I going to have? I'm going to multiply first by 1 with everything that is in the bracket. I'm just going to remain with 2 plus x. Okay, then let's start. Let me now multiply 2x with everything that is in the bracket. I'm going to have plus 4x, so this plus 4x plus 2x squared, okay, is equals to, when I come to the other side, let me now solve this. Let me start with the 1 multiplying with everything. So when 1 multiplies with everything, I'm going to have 2 minus x. Then now let me start with the, then now let me go to the negative x. Negative x multiplied by 2, that will be negative 2x. Then I have positive x squared. Then what am I going to do? I put the like terms together. Okay, so when I put the like terms together, what am I going to have? Let's see. So this here gives me a negative 3, right? Negative x minus 2x, that's a negative 3. Okay, when I take the negative 3 to the other side, this side have x, this side have x. This is 7x, right? No, it's 5x. So 5x, so this is 5x. When I take the negative, this negative 3 to the other side, it gives me a positive. So the x, I'll just have 8x. So I have 8x this side. Okay, is equals to, this side I'll remain with x squared. Okay, I'll take the 2 to the other side, it becomes a negative. So when it becomes a negative, you are going to realize that the 2 and this 2 will cancel, right? So the 2 are gone. Okay, this is also gone. Now this is also gone. We are just remaining with plus 2x squared. Then what do we have? I can take the negative x, the x squared to the other side. So I'll have 8x. When I take it to the other side, it just becomes a negative. So I'll have plus x squared is equals to 0. So now I'll just solve that expression to find my answers. So to find my answers, I'm going to say, allow me to write on top. So I have 8x, I'm saying it's 8x plus x squared is equals to 0. So what am I going to do? Let me try to factor out x. So I have x of 8 plus x is equals to 0. So therefore x will just be equals to 0, or 8 plus x is equals to 0. So therefore your x will just be equals to negative 8. So I have two answers, x is equals to 0 and x is equals to negative 8. However, we must always check these solutions in the original equation to ensure that they do not make any denominator 0. Okay, so you check your solutions and you find the answers like that. Good. Let's solve the last one. Okay, now for the last one, very interesting one. Okay, so we're saying 7x over 3x plus 1, this is equals to 4 minus x. So how are we going to solve that one? So personally, what I can do, I can multiply the whole expression by 3x plus 1. Why? Because I just want to have a straight line. Okay, so here there is 1. If you want, you can cross multiply. Okay, so, it's still fine, but you can also multiply with 3x plus 1, which is the same thing. So this and this one will cancel on my left hand side, so I'm just going to remain with 7x on this side is equals to, then 4 minus x is multiplying by 3x plus 1. It's just the same thing as when you cross multiply. Now that principle is very important because it works for a lot of equations that you're going to be solving. So now what do? You expand your expression. So I'm going to have 7x. I'm going to be multiplying 4 with everything that is in the bracket, so I'm going to have 12x. So I have 12x plus 4. Then I'm going to multiply by negative x with everything that is in the bracket. I'll have negative 3x squared. Then I'll have a negative x. Then I put the like terms together. So what can I have? So I have a negative x and a 12x. That will give me 11x. That 11x, when I take it to the other side, it becomes negative. Okay, it will be negative 11x. Then I have x, so 7x minus 11x, that will give me something like is it a 4? Yes, so I have a negative 4x on this side is equals to, then I've said this one has gone, this one has gone. Then I have a 4 minus 3x squared. So I can take these ones to the other side. So I have 3x squared, minus 4x plus 4. So this becomes a quadratic. Then you have to check if you can use the product in the sum method for this one. If you can't, you go for the quadratic expression or the quadratic formula. So this is how you also solve this one. Let's go to question number 6. Solve each inequality and show your solution set on the number line. Wow, this is very interesting. It's rational equations, but now these ones are rational inequalities. Like I said, for rational inequalities, you have to be careful with this thing for for cross multiplying here and there. Okay, because it's no longer an equation, and let me say just a normal equation, but there's an inequality symbol. So you cross multiplying with the inequality mostly tends to give you wrong answers. Okay, so what are we going to do? Again, for me to remove the fraction down, I can just multiply by the same fraction throughout. So when I multiply the fraction throughout, I have x plus 3. This is multiplying by x plus 2 is equals to, so this and this will go, so I just have a 12 like that. Oh, actually it's not equals to, it's the inequality itself. So you have that expression, then you solve it like that. So I've done that because it works. But if you want, you can also take, you don't cross multiply, you take this to the other side. Okay, you take it to the other side, then you solve. Allow me to solve it on the next page. Okay, so we have x plus 2. This is less than or equal to 12 over x plus 3. So let me just do the way I was saying. X plus 2, when I take this one to the other side, it will be negative 12 over x plus 3. The inequality is still intact, is equals to 0. I'm going to put a 1 here, then I'm going to merge these fractions, so over x. Then when 1 multiplies by this, just gives me the same expression. So that expression will be multiplying by what is on top. So I have this, it's multiplying by x plus 2. Then this expression, this into that, just gives me a 1. A 1 multiplied by 12, I have a plus 12. Okay, so that was the expression that we're supposed to have. So now I've got these equations. So you can solve what is on top. You can expand what is on top to find what you have. Okay, so what are we going to have with what is on top? So okay, so what are we going to have? X squared. Okay, let me just do the math. So x multiplied by x, that is x squared. Okay, multiplied by 2, that is plus 2x, then plus 3x, then plus 6, then we have a plus 12. Let me first solve what is on top. I'll ignore what is everything. So I have x squared, okay, plus 2x plus 3x plus 6. Okay, we're correct. So what are we going to have? We have x squared plus 2x plus 3x, that is like a 5x. Okay, 6 plus 12 6 plus 12, that is like plus 18. Okay, over x plus 3. So you solve this, you find your answers, then you also have this one, then you come up with a solution set. Okay, or the other expression that I had solved, even simpler, because I don't want to start solving quadratic expressions. So the other expression that I did was when I distributed the x plus 3, I had x plus 2 multiplying by x plus 3. This whole expression was equals to, was that to 12. Okay, because this and this one were cancelling. Then you solve what is in the brackets. So what when you solve what was in the bracket, we got x, that was like x squared plus 3x, okay, plus 2x plus 6, this whole expression to 12 like that. Then x squared is equals to, plus we are going to have 5x, right? 5x plus a 6. This whole expression is greater than, is less than or equal to 12. Then what are we going to do? Factorize this. Which two numbers can we multiply to give us 6? Then when we add them, they'll give us 5. So 6 and negative 1, if I say 6 and 1, what's there? 6 and 1, okay, it doesn't work still. It can't work if we say 6 minus 1. Unless if it was a negative. Okay. So what I'm going to do is, I'm going to say x squared plus 5x plus 6. I'm going to take the 12 to the other side, becomes negative 12. This is less than or equal to 0. Okay, actually that's when now it becomes correct. So say x squared plus 5x, 6x minus 12, that is a negative 6. Okay, this whole expression is less than or equal to 0. Now it makes sense. So therefore my solution will now be, it will just be what is it going to be? I'm just going to have I'm going to say x plus 6, and the other one we said is x minus 1, right? So x minus 1 is less than or equal to 0. Those are two numbers when you use the product and the sum method. Then you test these intervals. You're going to test these intervals. Okay, so let's say this and that, because there are only two. So this is what I'm going to do. I have x plus 6. I also have x minus 1. What are these ones doing? They're multiplying, so we're finding the product of the, and then what would be the values of x? So x will be equals to negative 6, and x will be equals to 1. It's equals to 1. Okay, or I just use the same inequality. I'm going to say x plus 6 is less than or equal to 0. So x will just be equals to, it will be less than or equal to negative 6. The other one would be x minus 1. So x minus 1, I'm going to, x minus 1 is less than or equal to 0. X will just be less than or equal to 1. So these will be your solutions. Okay, these will be your solutions. If you are using that, you want all the numbers of x that are less than or equal to negative 6. No shine about it. Okay, so I think I don't even need to do the signs here, because we usually do the signs if we want to graph this function, okay, to see where our solutions are going to be lying. Okay, so these will be, the solutions. So And that's how we're going to solve all these other ones the way I've solved this one. That's how we're going to solve all of them. Okay, then what other questions are there? Any questions that we are remaining with? Sketch the graph. Okay, now here there's sketching of the graphs. Okay, sketching of the graphs. Okay, so the last question is what question? Is it question? Okay, so question 8 is the last one. Okay, so let's sketch these graphs. Let's start with the first one. F of x is equals to 5 over 2x plus 8. So we are saying a, so this is 7a. We are saying f of x is equals to 5 over 2x plus 8. Okay, so what are we going to do? Like we always do, get what is, find the vertical asymptote, find the horizontal asymptote. So in this case, what is our vertical asymptote? Get what is down, equated to 0, because you don't want a 0 as your denominator. So you're going to say 2x plus 8 is equals to 0. So 2x is equals to negative 8. So x will just be negative 8 divided by 2, that is just a negative 4. So that is the vertical asymptote. The line, our graph should not touch that point on the x-axis. Then the vertical asymptote, the horizontal asymptote is about the y-axis. Now, when the value of the denominator is greater than the value of the numerator, the horizontal asymptote to be at y is equals to 0. So this what we have is enough for us to graph. Okay, is enough for us to graph. Then like everything that we are talking about we solved, and there are videos on these ones. So to gain even more insight, please watch the videos. You will save yourself a lot. So what do we have? We are saying our horizontal asymptote is at y is equals to 0. So this is y is equals to 0. So our graph shouldn't touch this line of y. Then our vertical asymptote is at x is equals to negative 4. So x is equals to negative 4. Let me put my negative 4 here. So it means the graph shouldn't also touch this point on the x axis. Then you draw your graphs. Okay, if you get any number, if you get any number that is less than negative 4, you put in the equation here. If we say a negative, let me say negative 5. Negative 5 multiplied by 2, that will give me a negative 10. Okay, negative 10 plus 8, that is just like a negative 2. So you're able to see 5 divided by negative 2, that is just a negative number. So you're able to see that this region gives me negative numbers. So the graph is going to move only in the negative direction, but it will not touch the vertical asymptote. Okay, however, if we had a positive number, our graph would have gone like that. Okay, so that's the difference. Then if we get any number that is greater than negative 4, let's say we get even a 0. If I put a 0 here, what am I going to have? I'm going to have 5 over 8. That is a positive number. Then let me say if I put any number that is even very close to negative 4, let me say I put a negative 3 here. Negative 3 is greater than negative 4, right? 2 multiplied by negative 3, that is like a negative 6. Negative 6 plus 8, that is like a 2. Okay, so you're able to see that all the numbers are giving me positive numbers. So the graph, the way it's going to move, it's just going to move in the positive values like that. So this will be our graph, but now you're able to see that it's also cutting the y-axis at that point. So because it's cutting the y-axis at that point, you have to find that point. So what you're going to do is that on the y-axis, x is what? X is equals to 0. So you're going to say f of 0 is equals to 5 over 2 0 plus 8. So we are going to have 5 over 2 multiplied by 0, that is 8. So that point is 5 over 8. 5 over 8, when I punch on a calculator, 5 over 8 just gives me like 0.625. So this point is like 0.625. Okay, that's that point. So you would have graphed your expression like that. Simple and straightforward. Let's solve then another one. So b is 6 minus x over x minus 4. So I'm saying f of x is equals to 6 minus x over x minus 4. Okay, so what are we going to do? Okay, on the previous graph, we are asked to state the domain and the range and clearly identified all the intercepts and asymptotes. Okay, so in that graph we just showed the remember our graph was something like that. I think if I remember very well, this was -4. Okay, then our graph went something like this, and it also went like that. Okay, so now the domain and the range, you're able to see that the domain is the values of x, right? The x values. Then for the x values we said we just don't want 4. Okay, we just don't want 4. Want everything, but we don't want 4. Okay, we found that our vertical asymptote was sorry for that. Yes, so we found that our vertical asymptote was at x is equals to -4, which is this point. So we want all the values, but x should just not be equals to 4. So we want all the values, but x should just not be equals to 4. That's what the domain will be. The range, you're able to see that our horizontal asymptote was at y is equals to 0. So we want all the values, but we just don't want 0, because our graph we said shouldn't touch this 0. So we're able to see that these ones are going like that, they are not touching 0. Even on the other side, they are not touching 0. So want all the values, but we just don't want 0. So y should not be equals to 0. So that would be our range. Okay, so that's how we solve. That's how we show the domain and the range. Very simple on the graph. Okay, so let's solve this one. So how do we solve this one? Okay, you're able to see as well. So let me just graph it fast, because you're even able to predict. For graphs, things are easy and straightforward when you're using graphs. So what are you going to have? So to find your vertical asymptote, equate what is in the denominator to be equals to 0, because you don't want a 0. It will make the function undefined. So x minus 4 is equals to 0, so x is equals to 4. Okay, our graph can be anything, but x should not be equals to 4. That's what we mean. So let's say our 4 is here, so shouldn't touch 4. Then our horizontal asymptote, let's look at the values of the value of x is x. They have the same power, right? The power of 1. So when the powers of the denominator and the numerator are the same, look at the coefficient, their coefficients. So this has a coefficient of 1, this has a coefficient of -1. -1 divided by 1, that is just a -1. So our -1 will just be here. Let me say this is our -1. So y can be anything, but y should not be equals to -1. Why? Because it will make the function to be undefined. Okay, so that's what we have. Now where is our graph going to be? Okay, where is our graph going to be? So you look at the values again. We have 4. If we get any number that is greater than 4 and we put it in this equation, let's say we put 5 here, we also put 5, what are we going to have? You're going to realize that you're just going to have positive numbers. Okay, the answer will be positive. So it means our graph, it will be in this region, the positive region, not in the negative region. Okay, it will be in the positive region. Then on the other side, on this side, if we get any number that is less than negative 4, less than 4, let's say we get a negative even just 2. If we put 2 here, we put 2 here, what are we going to have? You're going to realize that on top 2 minus 6 minus 2 to give you like a 4 over 2 minus 4, that will give us like a negative 2. So 4 divided by negative 2, that will be negative 2. So able to realize that when you get any number that is less than 4, it gives us negative numbers. So how is our graph going to be? It's going to move and it will go like that. It will not touch the vertical asymptote. So this will be your graph. Okay, so now it has cut the y-axis at that point. It has also cut the x-axis at those points. So you find those points. So if I'm going to find the y-intercept, okay, let me start with the x-intercept. Okay, let me start. Let's say f of, on the y-intercept, x is equals to 0. So f of 0 is equals to 6 minus 0 over 0 minus 4. So I have 6 over negative 4. That is just the same as 3 over negative 2. Okay, when I divide 3 divided by 2, that is just like negative 1.5, right? So let me say this point to be negative 1.5. Okay, now let's find this other point. On the x-axis, y is equals to 0. So I'm going to say 0 is equals to 6 minus x over x minus 4. When I cross multiply this multiplied by 0, it will just be 0. So 0 is equals to 6 minus x. When I take the 6 to the other side, it will be negative 6 is equals to negative x. So x will just be equals to 6. So this point where the graph is cutting the x-axis, it will be 6 or 6, 0. So that's how you solve these graphs, and everything follows. Everything follows, and very simple like that. So the domain and the range, for this function, what is it going to be? What to be the domain? What to be the range? So the domain, we said we don't want everything, but we just don't want 4, right? Okay, everything will exist, but just not 4. The range, we said everything should exist, but not just the negative one, the negative one, like that. Okay, so want everything for y, but you just don't want negative 1. That would be the range. Okay, then let's solve something that has I've seen some quadratics. Okay, a rational function that has a quadratic down, these ones on our left side. Okay, so which one should we solve? Okay, let's solve one that is a bit complicated. Let's solve E. E is equals x plus 3 over x squared plus 4x minus 5. Okay, so we're saying f of x is equals to x plus 3, this over x squared plus 4x minus 5. So how are you going to solve this one? So I think by use of a graph it will be fine. So this to find the vertical, the what do you call this, your vertical asymptote, equate this one to be 0. So x squared minus 4x minus 5 is equals to 0. Then you solve. Let's look if the product and the sum method can work. Our product in this case is negative 5. Our sum is negative 4. Two numbers that we can multiply, they give us negative 5, but when we add them, they give us negative 4. Do we have such numbers? Okay. So negative 5 and 1, right? Yeah, negative 5 and 1. Negative 5 and 1 will work. So this one will just be x minus 5 or x plus 1 is equals to 0. So x should not be equals to, or x equals to 5, or x is equals to negative 1. So these will be these ones will be the asymptotes. Okay, then what other thing do we have? We also have a 3. So we can also say x plus 3 on top. The one that is on top, if let me give you an example. The one that is on top here, if they give you just a constant number, like let's say just 4, it means you don't have let me say an intercept at that point. Okay, but if they give you this expression, it will have an intercept. But if you only have a constant on top, the one on top, it won't have an intercept. But this one has an x plus 3. It's not just a constant, so because of that, it also shows a shift in the x. So you also have to equate it to 0 to find the point at that. So x is equals to 0, so x is equals to negative 3. So we've got 3 values of x. Okay, so you are going to now graph this one. Very, very important. So let me just graph it in advance. Let me say this is our y, this is our x. Okay, so this is interesting. So we've got values such as negative 3, negative 5. So let me start with negative. Let me say negative 3 is here, negative 1 is there, and our 5 is there. Those are the answers that we have. Okay, so now what are we now going to have? Is this x plus 1? Okay, yes, it's just like that. So these ones will be the asymptotes. What have I done? No. Yes, so this would be negative 5, this is negative 3, negative 5 there, and our 1. Okay, so when our graph shouldn't touch these points. Okay, our graph shouldn't touch these points. Then the horizontal asymptote, look at the power of x and look at the power of x in the denominator is greater than the one that is on the numerator. So your horizontal asymptote will just be x-axis, okay, which is just that. Then you test your solutions. If you get any number that is less than negative 5, you put it in the whole equation. What are you going to have? Okay, so you're going to be testing numbers and numbers and numbers like that. Let me say if I get a negative a negative number, let me just see if I'm just going to be testing on the denominator. Okay, if I say negative 6 squared, that is negative 36, that will be positive 36. This negative 6 here, it will give me, so okay, actually the best one is to test the one on top, because we'll be dividing by that. So this will be negative 6 on top of a negative number. So then down here, this is negative 36, this is 36, that's a positive number. This will be also a positive number. So you're able to see that this on top just gives me, this side gives me a negative. Okay, so meaning our graph will come, but it will not touch this one. I've just done on the negative because it's giving me a negative number. But if it was positive, I would have gone like that. Okay, let's come in the middle. If you get any number between -5 and -3, let's say a -4, if you put a -4 here, -4 squared, or I also put a -4 on top. If I put a -4 on top, what am I going to have? If I say -4 here, so on top I have a negative. Even down I'm also going to have a negative. Down, am I going to have a negative? Let me see. -4 squared, that is 16. -4 multiplied by 4, that is -16. So actually I'll have a positive, because 16 minus 16, that is 0. I have a negative down, I have a negative on top, so they'll give me a positive. So in this region I'm going to move only in the positive, okay, but not touching the asymptotes. Okay, good. So I'll end from there. Then I come in the middle between -3 and 1. Let me pick a number like 0. If I put 0 in the equation, 0 squared, 0 here, I have a negative down, 0 there, I have a positive. So I have a negative down and a positive on top. So therefore I have a negative. So I'm going to the negatives. So this graph is going to go, pass through this point, and it is going to cut the x-axis, and it's going, but it's not going to touch this asymptote. Okay, this asymptote at 1. Okay, then when I come to any number that is greater than 1, if I put it in there, like let me say even just any big number, if I choose even a 20, I put it there, I'm going to have a positive number. So it just I'm just going to show that like that. So this will be your answer. So what your work to just be able for you to find where it's cutting the x-axis and where it's cutting the y-axis, and you're done with your graph. Then what other thing? You find your range and your domain. You're able to see that the range, we said we just don't want we don't want one. How can I say the domain? Let me start with the domain. The domain, we said we don't want -5, and we also don't want 1. Okay, we don't want -1 and -5 and 1. Why? Because they're giving us 0 in the denominator. Okay, so we want everything, but we just don't want -5 and 1 for the domain. For the range, you're able to see that we want everything, but we just don't want, okay, there's 0, but you've seen that this graph which went like that, it had to cross the vertical, the horizontal asymptote. So you're able to see that for the range, we want all the values. How can I say this one? So the range will just be at we don't want which values don't we want? We don't want which values won't we want? We want all the values from negative infinity, because these are the positive values of x, y, these are the negative. So we want all the values from negative infinity to positive infinity. So it will even pass through all the points like that. Okay, so everything will exist. So that's how you're going to solve this one, and the precurrent questions, even the questions that are coming. Let's solve the last question. Sketch the graph of each of the modulus functions. Okay, we've solved a lot of modulus functions, but now these ones are quadratic moduluses. Okay, I'll just solve the first one because it will simplify everything. Okay, y is equals to the modulus of x squared minus x minus 8x. Okay, so let's solve this one. So we are saying y is equals to the modulus of x squared minus 8x. Okay, so how do we solve that one? Get what is in the modulus, equate it to 0. So I have x squared minus 8x is equals to 0. Why are we doing this one? We want to find the shift in the x, or where the graph is going to start from. So I'm going to factorize the x, so I'm going to have x minus 8x is equals to 0. So therefore x will be equals to 0, or x will be equals to 8. So these are the 2 points that I have on my graph. So let me graph these ones. This is our y, this is our x. Okay, then what am I going to, okay, let me just put my graph nicely. This is my x and this is my y. Okay, let me put it like that. Now what are we saying? We've got x is equals to 0. 0 is just here, right? Okay, 0 is just there, 0 is here. Let's say our 8 is here. Okay, so now we have to find the turning point. Okay, so you know that modulus functions, they always go in that, but now this is a quadratic, because a quadratic, it was supposed to come like that. It goes and it passes through these points. Okay, now you know that for a modulus, you're not supposed to have negative numbers, because look at the value of the function is positive, so you don't want any negative values of y or x. So what are you going to have? So the way I've drawn it, you find that the ones that is in the negative is going to be reflected up. Okay, it's going to be reflected up, and this in short tape, we're just going to like rub it. That's what we're talking about. Okay, so that's how our graph is going to look like. So it means our graph is going to have a turning point at this point. So if you want to be wise enough, just find your turning point, you are good. Okay, when you find it, how do you find the turning point? The turning point, you know, of the graph, you're just going to say, is it x is equals to negative b over 2a. Our negative b, our negative, it will be negative, it's negative 8, right, over 2a is 1. So on top we have 8 over 2, that is just a 4. So we have a point 4, this is 4. Now what will be there? We have a point 4. Okay, 4 is for x actually. So the this one is x, so 4 is here. Now what will be the y value at that point? Okay, so you get the y expression and put and solve for, so that you find because you find that your x is equals to 4, so you're going to say y is equals to the modulus of 4 squared minus 8 4. Then you solve. So 4 squared, that is just like a 16 minus 8 multiplied by 4 is that 32. Okay, is equals to the modulus, always the modulus. 16 minus 32, that is just a negative 16. The modulus of 16, it is just 16. So this point is 4 comma 16. So that is your turning point. So the graph is going to, the normal way a quadratic comes, but it's not going to be go down, but instead it's going to be reflected up through this turning point. It's going to go at 8 and it will proceed like that. So this will be your graph, and that's how you're going to solve all these other expressions that you have. So solve, you find the values of x, then find your turning point, and it will solve you a lot. So this is where we're going to end from for today. See you in the next session.